Okay, let's continue our discussion here on solving these systems of equations as we talked about in class. Remember, we are looking for the solution, aka the ordered pair or ordered pairs, that actually work in both of these equations right here. And the ones we did in class, we had one solution where they were intersecting. We found that point of intersection wherever it was, and that was the actual ordered pair that worked in both. Yes, after we checked it. Now, let's do these two. They are a little unique, and that's why I wanted to do them on here for you so you can see. You should copy these right there in your little your graphic organizer or whatever notes, wherever you want to do it. But let's graph this together. So it'll be a reiteration, which you already know in terms of graphing, but we're going to see some funky things that happens with this. So let's do this. Let's see, let me change my color here. Let's make this equation number 1. I'm going to make that one green when I graph it. This one right here, I'm going to make equation 2. I'm going to make it pink when I graph it. So I'm going to do this one first. Why modder? Because it's already in slope-intercept form. It's a little easier. So I'll put a dot here on -3. That's my y-intercept. And then I'm going to go use my slope, 2 over 1. So I go up 2 over 1, 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 and so on and so forth. So it looks just like that right there. Down 2, back 1. Down 2, back 1, down 2, back 1. So it looks just like that, and I'm going to graph my line. Whoa. I'm going to graph my line right up through there. As straight as I can get. This thing I'm drawing on is actually not the easiest thing to draw on. I'll get there, don't worry. Wow, yucky. So something like that. That is yucky, yucky. Oh my. Okay, whatever. It's a straight line. Picture being a straight line. So, there is that one. Now, let's change my color, and let's graph this guy right here. Well, here's what I'm going to do. I'm actually, no, you know what? Let's put it in slope-intercept form. So let me subtract 4x. I'll do it over here so we can see it. So it's -2y. Once I subtract 4x on both sides, it gives me equals -4x plus 6. And then I got to divide both sides by -2, -2 here, -2 here, which will give me these cancels. I'm left with y equals a 2x plus 3. I believe it's how it looks. Oh wait, never mind, sorry. That's a -2. So this actually, let me back that up. This would be a -3. Because that's a -2 right there. Almost made a mistake. Okay, so let's take this now. We'll graph it. That's the equation, the first equation. I'm going to graph it in green. So at -3, hey, look at that. Looks pretty cool. Right on top of the other one. I'm going to graph this. I'm going to go up 2 over 1. Up 2 over 1. Wait a minute. What's happening here? Up 2 over 1. Well, this is interesting. Notice, I am graphing the same exact set of ordered pairs with this line as I did this one. If I kept going down here, down 2, back 1, down 2, back 1, down 2, back 1. Well, that's weird. So if I graph this line, it's going to be right on top of that pink one. Well, that is weird. Now, if you really look at this over here, you would have seen that because I tried to do it quick so you didn't see it. But if you look at this equation compared to this equation, you can see, guys, they're exactly the same thing. So what's my solutions? It's still the same as we talked about in class. Anywhere these two graphs would intersect, we're looking for the point or points of intersection of these two lines. Matter of fact, here's the crazy thing. They intersect, the red one and the pink line, they intersect at every single ordered pair that you see because they lie directly on top of each other. So what does that give us? What's the solution? Is it 2, 1? Is it 3, 3? Is it 4, 5? What is it? That's a really good question. The answer is this. It is infinite, many solutions. There isn't just one. There isn't just two. There's infinitely many because they lie right on top of each other. So what did you just learn right here? Well, one, you know it's possible to have infinitely many solutions, not just one little order pair. Oh yeah. And it happens whenever you actually have the same exact slope, same exact y-intercept, aka the lines are exactly the same. Same lines. Bam, there you go. So there's one unique one, no doubt. A definite unique situation. So let's go to example 2 and find out what the unique one is, the uniqueness of that one is. Alright, onward to example number 2. So again, I'm going to reiterate what you already know in terms of graphing the lines, but you'll see something that kind of comes up here unique. So let's do this. If you want to pause the video and graph these yourself and see how they look, do it. If it was me, I'd do it, just to kind of see if I'm on board with all this stuff. So let me change colors. Let's make one red and purple, whatever. Okay. So the first I'm going to graph, oh boy. You know what, let's do this. Let's do x and y intercepts for this first one right here. So I'm going to put a 0 in here. That means the y-intercept will be 3. So at y, I'm going to put a dot at 3 on my y-axis. Okay. Wait. Actually, hold on. Back up. So I'm going to put a dot here at 3. Now, if I put a 0 on there, that means x would be a 2. That's my my x-intercept for that one. So let me erase that. Okay, so I got a dot here. My y-intercept is 3. My x-intercept again was 2. So there we go. So that line right there will go down through, let's see, what is the slope? 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. 3, 2. 3, up 3, back 2. Up 3, back 2. Beautiful. So there, so that'll be good again. Kind of feels like I'm doing an Etch-a-Sketch. You have no idea what I'm talking about, but there we go. Okay, so there's that line. Oh, man, I completely messed this up. Hold on a second. Let me change this. Instead of me just doing this, let me just erase this. Let me erase this and make the colors right. So this one now is number 1, the red one. Now let me do this one in purple. Okay, so, well, there's not really an easy way to do this, and then I see with x and y intercepts. So let me just do this. Let me put it in slope-intercept form. Divide by 2, divide by 2. So that means I get y equals negative 3 over 2x, and that's plus 1. So this is the equation of my second line. So I'll start at 1. Hey, okay, look. Well, now you know immediately this does not have infinitely many solutions. Why? Because this dot isn't even on there. And this dot right here, that order pair, the coordinates for that order pair represent a solution to this. So you know it's not infinitely many solutions. So let's look for maybe the order pair where they intersect. Let's see. Down 3, this is the slope, down 3 over 2. Down 3 over 2. Down 3 over 2. Down 3 over 2. This one I'll go up 3, 1, 2, 3, back 2. Up 3, back 2. Up 3, back. Well, this looks weird. So if I graph this line, guys, even though my lines are very wavy, what's the deal with these guys? You got it. These lines, are parallel. They are parallel. So, what does that mean? What's the solution to this system of equations? Remember, we're looking for the ordered pair, the point in which these things intersect, aka that gives you the ordered pair that actually then works in both equations. They don't intersect. Mater, what's the deal? Well, guess what? It is completely possible, as you see in this example, where there are no such ordered pairs that exist that you can plug into this x and y and make it work, and also this one and make it work. It doesn't work. You can find infinitely many that work in just this first equation, likewise in the second equation, but you won't find any ordered pair that works in both. And that means no solutions. There are no solutions at all. No solutions to this particular system of equations. Also notice visually, they don't intersect. So it is possible to have no solutions, and that's whenever you have parallel lines. So that's pretty cool. So there's what we just learned. We learned when we have this, you can have the same exact lines. So they have same actual slope and same y-intercept. That's infinite many solutions. This guy right here, you actually have parallel lines, no solutions when that's a possibility, or when that happens, because there's no intersection. By the way, last thing I want to show you is this. Let me take this equation right here and show you how the slope is exactly this. Because remember, when we have lines that are parallel, that means they have the same exact slope. So if I would subtract this guy, 3x plus 2y equals 6. If I subtract 3x from both sides, that would give me 2y equals negative 3x plus 6, and then divide by 2. Take a look at that. So I would get the same thing. This would cross off, so I'd be y equals negative 3 over 2x. That's the same slope right there. And then this would be plus a 3. So I have plus 3 is my y-intercept, plus 1 is my y-intercept, but notice the actual slopes are the same. That's why they're parallel, and they're not coinciding lines, because this guy and that guy are completely different y-intercepts, but they do have the same slope. So there you go. You got no solutions and infinitely many solutions. Rock and roll. There's our special ones. Again, like I said in class, 95% of the time, goodness, they're going to be ones that actually do cross somewhere, and they actually do have a solution, one ordered pair that works. But it is possible to have infinitely many and no solutions. Later.